So in this video, we're going to be looking at rigid motions and parallel lines, test practice 2. All right, so remember the first one, the first rigid motions assignment that we did was with the shapes. We were just moving the shapes around. Now we're going to be doing the same thing except with parallel lines. All right, so let's read this first question. This first question says, suppose a coordinate plane contains line L, line M, line P, and line Q. Okay, so it's saying there's 4 lines so far, okay, and the coordinate plane. So here we have the coordinate plane. If all that is known is that line L is parallel to line M and line P is parallel to line Q, what must be true after all of the lines are reflected across the x-axis? All right, so maybe we'll start off with the keywords like we did in the previous test practice video. Okay, so maybe we'll look at, let's see, what's a nice word to look at here? I think reflect is important, okay, because reflect is a rigid motion, right? We know reflections don't do any, they're not going to change the parallel lines, right? They're not going to change the lines from being parallel. If you reflect parallel lines, they're going to stay parallel. All right. So let's go ahead and graph these lines. Okay. We really don't have to graph these lines. Okay. It's more conceptual, but let's go ahead and graph them. Let's see what happens. All right. So let's say we have a line. We'll have this line. Okay. We'll have maybe we'll take a line parallel to that line. So we'll do a parallel line to this line, maybe here. Okay. Now let's take another line. Okay. So maybe we'll say, okay, so it said line L, right? So maybe we'll say this one's line L, and we'll say this one right here is line M. Okay. And now let's see something. Let's see if we can do another line. So let's make another line. Maybe this one will look like this. Maybe it'll look like this. Okay, or like this maybe. All right, like this. And another parallel line. We'll do a parallel line to this line. All right, there we go. Okay, so maybe this is line L, this is line M, okay, this is line P, and this is line Q. All right, so now it says if all that is known is that they're parallel, okay, so we know line L and line M are parallel, and line P is parallel to line Q, okay, so we have this right here, these two lines. What must be true after all of the lines are reflected across the x-axis? Okay, well, let's see what happens when we reflect across the x-axis. So we'll find reflect. Let's see, we should have reflect around here somewhere. Okay, here we go. Reflect about line. So we'll do reflect. So we'll click this line. Oops. So we'll do reflect about line. We'll take this line and we'll reflect it about the x. Okay, so here I just reflected this line about the x-axis like it told me to. Okay, and now I'm going to reflect this line across the x-axis. Okay, so now as you can see, I took both of these lines and I reflected them. Okay, so there's like a mirror here now. Okay, so they got reflected. All right, but now that the question says all lines. All right, so all of the lines need to be reflected across the x-axis. Okay, so let's reflect these two over the x-axis also. So we'll click it and we'll click the x-axis. Okay, and we'll click this one and we'll click the x-axis again. All right, so yeah, maybe it looks a little crazy right now, but that's okay. All right, what's most important is that you just try to visualize this one, these new parallel lines by themselves, okay, and these this one and this one. All right, these two right here are going to be these parallel lines, and all it's saying is what must be true after all the lines are reflected. All right, guys, so the key word here is reflected. Okay, so what happened here? Well, they stayed parallel. Okay, that's all this question was about. Maybe was a little confusing, but sometimes it's nice to see it in the XY. So all we did was we took this one and this one, reflected over the x-axis. We got these two. We took this one and this one, and we reflected over the x-axis and got these two. Okay, and as you can see, they're still parallel. All right. So maybe when it says what must be true after all of the lines are reflected across the x-axis, we'll just say all of the lines remained parallel. because we reflected. And reflections are rigid motions that don't change. Oh, we'll say that keep lines parallel. Okay, that's pretty much all we had to do. All right, guys. So all of the lines remain parallel because we reflected. All right, and reflections are rigid motions that keep lines parallel. All right. You won't be doing any graphing on the test. Okay, this was just a little visual, just to see that they stayed parallel. Okay, these two started out parallel, reflected, stayed parallel. These two started out parallel, reflected over the x-axis. Okay, and then they stayed parallel. All right. So let's go to the let's do let's go to this next question. All right. So what's this next question say? This next question says lines BC and DE are parallel to each other and the y-axis. All right. So let's get some lines going for visuals. So let's say this is line. Okay. So first things first, right? So it says lines BC and DE are parallel to each other and the y-axis. Well, where's the y-axis? This thing is the y-axis. This axis I'm moving the mouse down right now is the y-axis. Okay, the vertical axis is the y-axis. And it says BC and DE are parallel to the y-axis. So we'll draw maybe this line right here. Should be good. Okay, and then we'll draw a line parallel to that. So we'll take a parallel line to this one. Parallel line to this one. So let's say we have these two. Okay, so let's just pretend this one's BC, okay, and this one's DE. This is line DE, and these are parallel to the y-axis, right? You can see that they're never going to touch. The y-axis and DE and BC are never going to touch. All right, so now what does it say? It says if the two lines were reflected across the x-axis, okay, and then reflected across the y-axis to form lines B prime, C prime, and D prime, what would be a true statement about the two lines with respect to the axes? Okay, so let's see what's going on here. So I think what we should do first is always highlight the words we like, okay, the words that are important. So if the two lines were reflected, it's a good word because it's a rigid motion, right? And this entire thing is about rigid motions across the x-axis, and then reflected across the y-axis to form lines B prime, C prime, and D prime, E prime. What would be a true statement about the two lines, okay, with respect to the axes, okay? So let's see. Well, here's BC and here's DE. The first thing they say is they were reflected across the x. So let's go ahead and reflect these lines across the x, reflected by a line. So if we reflect this about the x-axis, you're going to see nothing changes, okay, because it's like you're taking a vertical line and you're reflecting it over the x-axis, but it's just going to be the same exact line. It's not going to go anywhere, okay? It's going to stay right here. All right, it's like a stick. It's like take a stick and flip it over the x. It's still going to be just like that, all right? Same thing with this one. If I reflect this one over the x-axis, it's the same thing, okay? It's going to be the same line. It's not going to, it's the same thing, okay? So that's not going to change. Now it says, and then reflect it across the y-axis. Okay, so now they should move around. So we're still going to reflect about a line. Okay, so now we're going to reflect over the y-axis. So let's reflect this one first. This one's DE right here over the y. Okay, now we reflect it over the y-axis. So we're mirroring over this one right here. Okay, now let's reflect this one over the y-axis. Okay, so now we have these two. All right. So remember, this was BC. This was line BC. Now we have B prime, line B prime, C prime. Okay. This was line DE right here. Now we have line D prime, E prime. And what's it saying? It's saying what would be a true statement about the two lines with respect to the axis. So they're talking about the new lines. They're talking about these lines. They're saying what would be a true statement? Well, what could with respect to the axis? So that means say something about these lines with respect to the axes, okay? So what we want to talk about is the y-axis, right? Because the y-axis is parallel to these, and this entire thing is all about parallel lines. So we could say the lines B prime, C prime, and D prime, E prime are parallel to the y-axis after the rigid motions. Okay, that's pretty much all you have to say. It's just a little sentence, all right? Again, guys, this is just for you guys to visualize, all right? You won't be doing any graphing on the test. Okay, so we're just reflecting around. Okay, so that's pretty much all this problem was about. Let's go to number 3. Number 3 says, what happens if two lines are rotated 250 degrees? Well, what's the key word here? The key word here is, we know we have parallel lines, but a nice key word here is rotated, right? So we can highlight that. So what happens if two lines are rotated 250 degrees? Well, when lines are rotated, hold on, let's do a different color. So let's do blue. Let's see, let's do orange. You can say when lines are rotated, oh, I'm sorry, when parallel lines are rotated. When parallel lines are rotated, they remain parallel. Okay, it doesn't matter, right, guys? It doesn't matter how much you rotate. It doesn't matter if this was 1 degree or 2 degrees or 550 degrees. Okay, when parallel lines are rotated, they remain parallel. Okay, what's this one say? This next one says, what happens if two parallel lines are reflected across the y-axis? Okay, so we'll highlight reflected because it's important. It's a rigid motion. Okay, so what happens if two parallel lines are reflected across the x-axis? Well, we could say, we'll say it in orange. So we'll say when parallel lines are reflected across, we could really say across any line. Okay, it doesn't matter what you reflect across, right? When parallel lines are reflected across any line, okay, it doesn't matter if it's the x-axis, the y-axis, some line going through in the coordinate plane. It doesn't matter where you reflect. Okay, when parallel lines are reflected across any line, they remain parallel. Okay, let's look at this next one. This next one says, what happens if two parallel lines are reflected across the y-axis? So again, okay, so we have reflected, but same thing as before. So what we could really do here is just copy and paste this exact same answer down here, right? So when parallel lines are reflected across any line, it doesn't matter where they're reflected, they're still parallel, all right? And this last one says, what happens if two parallel lines are translated? Okay, there's translated. That's one of our rigid motions. Very important. Okay, what happens if two parallel lines are translated 20 units down in the coordinate plane? Okay, what we could say is, so that's like saying we slide two lines, right? So let's say we have a line here, okay, and let's say we have a line here, okay, and let's say we were sliding these around. So let's say we slider, okay. So let's say 1 second. So let's say we were translating. Okay, so we could grab it around. Okay, so you see we're sliding it. All right, you see we can slide this one too. Okay, it doesn't matter where you slide them. It doesn't matter it doesn't matter how you slide them. They're still going to be parallel. Okay, hopefully you guys can see that. All right. Yeah. Okay, so they stay parallel, just like the previous rigid motions. So we can say again, we can say when when parallel lines in general, when parallel lines are translated any amount, okay, they stay parallel. I will say they remain, to keep our vocabulary consistent, they remain parallel. All right, so that's pretty much all it's saying. It doesn't matter how much you translate, 20 units down, 50 units right, okay, they're still going to be parallel, okay. Let's look at this last question. This last question says, which statements below are true? Write down your answer. All right, so you're going to want to go ahead and respond to these on your paper. But let's read them real quick. It says, which statements below are true? If two parallel lines are rotated, okay, so maybe I'd highlight that. I will pay attention to that, okay? They will remain parallel, okay? So that's for you to decide. And if it's right, you can select it because it's asking you which statements below are true. So you're going to select the ones that are true. Then it says if two parallel lines are reflected, there's another important word, across the y-axis, they will not remain parallel. Okay, so that's for you to decide if that's true or not. Then at least C says if two parallel lines are translated, it's another important rigid motion. Translated 10 units to the left, they will remain parallel. Okay, that's for you to decide. If two parallel lines are rotated, there's another rigid motion that's important to recognize. 180 degrees about the origin, they will not remain parallel. Okay, so this one's saying if two parallel lines are rotated 180 degrees about the origin, they're not going to be parallel anymore. Okay, so that's for you to decide if that's true or not. Okay, this one says if two parallel lines are reflected, there's another important one, across the line y equals negative x, they will remain parallel. All right, so what's important here is to look at reflected, right? So if two lines are reflected across some line, they will remain parallel. Is that true? All right, and the last one is if two parallel lines are translated, there's another important word, 25 units down, they will not remain parallel. All right, so that's for you to decide again, and maybe I'll leave you guys with a hint, and the hint's gonna be select. Maybe I'll say there are only 3 true statements. All right, so from these 6 options you have, only 3 statements are true. So make sure you're only selecting the 3 that are true. All right, and make sure you just go ahead and write those down. All right, guys, that's gonna do it for this little practice on parallel lines. All right, so same thing with shapes that we did with shapes. We're just doing with parallel lines. All right, so what's most important is that you recognize, reflected, the rigid motions. All right, just that stuff. Okay, thanks for watching.